Intro. Hello everyone, and welcome back to our channel. Today, we're diving deep into the world of artificial intelligence and machine learning to discuss a critical aspect of AI development, building a scalable AI workflow. Specifically, we're going to focus on automating three key components of this workflow: data ingestion, model training, and deployment in production environments. Whether you're a seasoned data scientist or just starting your journey into AI, understanding these processes is essential for creating effective and efficient AI solutions. Section 1: Understanding the importance of a scalable AI workflow. Before we jump into the nitty-gritty of automation, it's crucial to understand why scalability is important in AI workflows. A scalable AI workflow allows organizations to handle increasing volumes of data without a corresponding increase in manual effort. As data grows in size and complexity, the need for efficient processes becomes paramount. A scalable solution can adapt to increasing demands, ensuring that businesses remain competitive and capable of leveraging their data for insights. Moreover, as AI models evolve, they necessitate regular updates and retraining. This means that the systems you put in place must be robust enough to handle these changes seamlessly. A well-designed workflow can significantly reduce the time and resources needed for these tasks, allowing teams to focus on innovation rather than repetitive tasks. Section 2: Automating data ingestion. Let's start with the first component: data ingestion. In any AI project, data is the lifeblood that determines the performance of your models. The process of data ingestion involves collecting raw data from various sources, cleaning it, and preparing it for analysis. Automating this process can save your team countless hours and ensure that the data pipeline remains consistent and reliable. The first step in automating data ingestion is identifying your data sources. Data can come from multiple locations: databases, IoT devices, web APIs, and even social media platforms. Depending on your application, you may need to combine structured data, like SQL databases, with unstructured data, like text or images. Once your data sources are identified, the next step is to implement data extraction techniques. This is where tools like Apache Kafka, Apache NiFi, or AWS Glue come into play. These tools allow you to set up workflows that automatically pull data from your sources based on defined schedules or events. For instance, you can create a Kafka stream that continually pulls new data from a web API, ensuring that your data is always up to date. After data is extracted, it often requires cleaning and transformation, commonly known as ETL: extract, transform, load processes. This phase is crucial, as raw data is rarely in a usable state. Here, you can deploy tools like Apache Spark or Talon to automate these processes. These tools allow you to create pipelines where data is cleaned, normalized, and transformed into a format suitable for analysis. Additionally, consider implementing data validation checks to ensure the quality and integrity of your data. Automated testing scripts can be run at different stages of the ingestion process to catch anomalies early on. Ultimately, the goal is to have a seamless flow of high-quality data into your AI system, ready for model training. Section 3: Automating model training. Now that we have consistent data flowing into our system, let's move on to the second component: model training. Training machine learning models is often a time-consuming process that can benefit immensely from automation. The objective here is to create a system that can automatically train and retrain models based on new data. The first step in automating model training is defining your training pipeline. This includes selecting the appropriate algorithms, hyperparameters, and evaluation metrics. Frameworks like TensorFlow, PyTorch, and Scikit-learn provide excellent tools for building robust machine learning models. However, the key to automation lies in using these frameworks alongside orchestration tools. One popular orchestration tool is Apache Airflow. With Airflow, you can create directed acyclic graphs, DAGs, to manage your training workflows. For example, you can set up a DAG that automatically kicks off the model training process whenever new data arrives in your system. This means that your models are continuously updated and improved based on the latest information. Hyperparameter tuning is another critical aspect of model training that can be automated. Tools like Optuna or HyperOpt allow you to automate the search for the best performing hyperparameters. By running multiple training jobs in parallel with different hyperparameter configurations, you can find the optimal settings without manual intervention. Additionally, consider using techniques like k-fold cross-validation to ensure that your models generalize well to unseen data. Once your model is trained, it's essential to evaluate its performance. Automated testing scripts can assess metrics like accuracy, precision, recall, and F1 score. If the model meets your predefined criteria, it can then be automatically pushed to the deployment stage. If it doesn't, you can set up alerts to notify your data science team for further investigation. This feedback loop is crucial for maintaining the quality of your models. Section 4: Automating Deployment in Production Environments. The final component of our scalable AI workflow is deployment. Deploying machine learning models into production environments can be fraught with challenges, but automation can streamline this process significantly. The goal of deployment is to make your trained models accessible for real-time inference or batch predictions. One popular approach to automate deployment is through the use of containerization. Tools like Docker allow you to package your model, along with all its dependencies, into a single container. This ensures that your model runs consistently across different environments, whether it's on your local machine, a staging server, or in the cloud. Once your model is containerized, orchestration platforms like Kubernetes can manage and scale these containers based on demand. Kubernetes can automatically adjust the number of running instances based on traffic, ensuring that your models remain responsive even during peak usage. In addition to containerization, consider implementing CI/CD pipelines for your models. CI/CD, which stands for Continuous Integration and Continuous Deployment, automates the process of deploying new model versions. Tools like Jenkins, CircleCI, or GitHub Actions can be configured to automatically deploy new models whenever changes are made to the code or data. This minimizes downtime and ensures that your users always have access to the latest version of your models. Monitoring is another critical aspect of deployment. Once your model is live, you need to ensure that it performs as expected. Tools like Prometheus and Grafana can be used to monitor various metrics, such as response times, error rates, and resource utilization. Automated alerts can notify your team if something goes wrong, allowing for quick intervention before users are affected. Another key consideration is model versioning. As your models evolve, it's important to keep track of different versions and their performances. Tools like DVC, Data Version Control, or MLflow can help manage the lifecycle of your models, enabling you to revert to previous versions if needed or analyze the performance of different iterations. Section 5: Bringing it all together. Now that we've covered the three major components of a scalable AI workflow: data ingestion, model training, and deployment, it's important to see how they all connect. The automation of these processes creates a cohesive system that can adapt to changing conditions and demands. For example, consider a scenario where a new data source is introduced. With a well-designed data ingestion pipeline, you can easily integrate this new source without disrupting existing workflows. Similarly, when it's time to retrain models, your automated training pipeline can pull data from the ingestion system, train the updated model, evaluate its performance, and deploy it all with minimal manual intervention. As we move further into the future of AI, these automated workflows will become increasingly essential. They enable teams to focus on innovation and experimentation instead of getting bogged down in repetitive tasks. By scaling your workflows, you're not just streamlining processes, you're positioning your organization to leverage the full potential of AI. Conclusion. In conclusion, building a scalable AI workflow through the automation of data ingestion, model training, and deployment in production environments is crucial for any organization looking to harness the power of artificial intelligence. By implementing these systems, you can ensure that your models remain up to date, perform well, and provide valuable insights. Thank you for watching. If you found this video helpful, please give it a thumbs up and subscribe for more content on AI and machine learning. Be sure to leave your questions and comments down below. We love hearing from you. Until next time, keep innovating and pushing the boundaries of technology.